Hello. So the things that I would like to do today involve the kanji database itself. And so first I'm going to explain a little bit about the files that we use to get our data from and the check kanji database order consistency check command. And we're going to fix that command because right now it's failing. It's finding an inconsistency in the database because of something we did last time. And then we're going to add this data source file to the repository instead of keeping it like as an external dependency. So put that in the Git repository, and then we're going to fix the command up a little bit so that it can run without sending a bunch of output to standard out, and then run it automatically as part of make, like with our other tests. Because make, as you know, will run all of the tests automatically, and these all pass, but check kanji database order does not pass. Check kanji database order. All right, so here it's saying that the sort key could not be found for this. And if you remember, this is tsukamuri, a radical, which is only in Japanese and it's not in Unicode. Well, it's not. What I mean by it's not in Unicode is that it's not used in Unicode's system of sorting. And so when they sorted Japanese characters that have this particular radical, because no Chinese characters have it, they kind of chose arbitrary other portions of the character to stand in for its radical. And so that way it had some kind of a sorting key to work with. So that's a problem. And so this data file, Unahan RadicalStrokeCounts.txt, let's take a look at it. Okay, here it is. So this has data about the kanji characters in the Unicode standard. And so the first column is the code point, or the kind of like numeric representation of that character. And next is the source of the data. Now, I'm not sure exactly what this means. KRS Adobe Japan 1.6. It probably refers to a dictionary or a database maintained by Adobe of Japan. And after that, we have a bunch of data about that character. Now, the first number is not important. So there's a C plus, a V plus heading for each like piece of data, and as you can see, it's each like piece of data kind of has a similar format. So it either starts with C or V, and I couldn't find any reason to ignore C or V. In other words, both the C and V data was useful at different times. So I actually read all of it and consider all of it. And next is the radical, and then the residue stroke count at the end. The third one, I believe, is just a number we don't really care about. It might be the stroke count of the radical itself, maybe. So we don't really use that in our IME that we're developing. So we just do this number and this number here. And check kanji database order command uses that to determine where it should be sorting those kanji. And so we also have this other file, CJKRadicals. And what this does is it gives you a index for that radical that Unicode uses, and it gives you the Unicode representation, the code point of the radical itself, and then the code point of the kanji that has that is that radical. So this was surprising to me. Apparently, Unicode has two code points for each radical that look exactly the same, and one of them is like represents the radical, and one of them represents the actual kanji, which looks like that radical. And I can't imagine why you would need both. But for one thing, it looks like the radical number kind of increments predictably from 0 and up, whereas the kanji character does not, because obviously it's including, because between each radical in the Unicode standard, each kanji representing a radical, there are other kanji in between that have that radical. And I did find this a bit surprising that there were two representations, but I'm pretty sure that we don't need to allow inputting this code point here, the one that represents the radical itself, because it looks just like the kanji character, and this tool is not going to exactly be for inputting like radicals exactly. It's for inputting linguistic stuff and stuff that can be read aloud. So, so yes, don't worry too much about the fact that there are two numbers here. So now what I did is, so now there's a check kanji database order command. Let's look at that real quick. So we want to go to check kanji database order. All right. So this reads all fields in Unahan radical stroke counts, which are from Adobe Japan. It doesn't use the other dictionaries because the other ones are either Chinese specific or maybe, I don't remember what all the other dictionaries were in that file, but one of them was like Kangxi, which is a kind of ancient Chinese dictionary, and it doesn't have the Japanese classification for some of the exceptional characters. So it reads from those fields, and let's look at the entry point and just kind of go over it very. Let's actually go to the process radical stroke count line, and SO means stroke count. It's an acronym that I chose when I wasn't concentrating, so it doesn't make sense. So process radical stroke count line, and this will skip all comment lines and all blank lines, and it looks like it tries to get the actual character code point out here, right? And then it checks to make sure that we're looking at a dictionary that we care about right here, and then it goes to the next data field right here, and at this line, and then it let's see what here, this makes it skip to this is what tries to recognize the end of the line or the end of the file, and here we are actually reading the data that we care about, which has the radical and stroke count information. And so it ignored that long number at the start, and it ignored the second to last number, which is the stroke count of the radical itself, and it reads in the stroke count, and it reads in the radical number and the residual stroke count here. And if it fails, it complains about a mistaken format. And here, it kind of fixes the radical numbers that we don't care for, right? So here it says that all the radicals that have one stroke are treated as the same radical. So for radicals 1 to 6 are treated as just the same as radical 1. And here we treat all the radicals that kind of look like legs or people and treat them all as a single radical, because they can be kind of confusing at times. And this pair of radicals, they look almost exactly the same. They will be treated as a single radical. And these two are a similar deal. This pair are also treated as a similar radical because they look almost the same. Well, they look exactly the same once they're shrunk down to the portion of the character that they're found in, and that's that. And so decode code point. See, what is that? Decode code point. So it looks like, I'm guessing what this does is it converts from UTF-16, which is just the raw. Oh no, so it takes the code point string, which is the hexadecimal numeric representation of the code point, and then it converts that to UTF-8 down here. Okay, so let's see here. And so we also have these extra characters. So I found that in the dictionary that it was using, the Unihan radical stroke counts, it did not have certain classifications for the characters that were found that I found that I considered normal, which could be backed up in like 2 or more other dictionaries that I just happen to have at hand. And so I ended up using those here and just kind of adding them manually as raw pieces of data. So, okay. Now, this is probably all we need to know to kind of like understand the basics of this command. At this point, you should be able to follow what I'm doing for the rest of the coding in this video. So now, yeah, the problem is now I'm worried that this kind of radical thing, this radical remapping, is going to get very complicated, because we actually have to add, not only are we considering certain radicals as the same, so we're conflating radicals, we're also going to be considering that some radicals are, we're also going to start to consider a radical in the middle of the sequence, which is like different. In other words, we're going to have a lot of kind of remapping here. And so I would like to add a table that makes this a little bit more manageable. And that table I'll use, the way I'm going to make that table is I'm going to use the CJKRadicals file, and I'm going to run this through a script first, and then I'm going to kind of get a readable representation of that. Right, here's the script, so to speak. Right, so I will copy that and I'll run it over here. Okay. Oh, it's running. It's sent it to my pager. Okay. Yeah, so this shows you the radical number here and the numeric representation, and then it shows you the kind of the actual radical itself. And this actually used the I don't really like this because it didn't use it used this first number here rather than the second number. So I'm going to change that. I'm going to have it print out the third code point rather than the second one, and that didn't work. Okay. So right, that's because we're grepping down here. We're looking for the lines that start with 2, which is not going to work. So maybe we can just invert that and look for lines that don't start with 2, and that will make this reasonable. Nope, that didn't work. So we're skipping lines with quotes because the quotes appear to serve as a kind of variant for the radical, from what I can tell. So we're skipping lines with these single quotes. And we're also going to get the third field here. Then, well, let's see. Okay, we want to, let's see what this looks like first. Okay, that looks good. So all these lines start with 4, 5, 6, 4 to 9, right? So instead of 2 over here, we're going to say 4 to 9. Okay, that didn't work. Well, let's see what the output looks like first. Oh, because I still have that dash V. That's why. Okay, that looks better. And so what comes next is this xargs thing. This tries to printf everything. Okay, that looks better. And then we want to number the lines. And there's some kind of a command to do that. I was using less, but I actually want this to be a, well, let's try that. Maybe I can write the file out. Um, okay, let me figure this out off screen. I'll figure out how to save a file with less. Okay, so the problem with using the s command in less, which saves a file, is that it doesn't include the line numbers that you added. And so what you can do instead is use cache minus cat minus n, and that will attach line numbers to a pipe that you send it. So here we have cat-n. So that's basically what I wanted. Now I'm going to remove this part of the line, this label, because we don't really need that. This kind of Unicode representation of it. I think we can just kind of skip that. And here. Okay, good. Now we have a kind of list of radicals with their numbers. And now I kind of want to have a hexadecimal representation of the line number as well as a decimal representation, because I think that that's going to come in handy. So I'm going to go ahead and run pass this through awk, because this is how this, I believe it's the easiest way I can figure out without having to look stuff up. And so we're going to pass to awk, and we will print. Let's make sure I'm remembering the syntax right. Okay, print one, print. But I didn't add the cat. So awk can actually print out field or line numbers inside of it. So let's just do it that way. Print f, and let's see here. So we want you want the numeric line number or the decimal line number. We want the hex line number, or the hex radical number, and we want the character itself. Send s. All right, and I believe that will work. And okay, let's try this. Oh, but we need to also add nr. nr. I believe that's how you do it. Yeah, good. That's pretty nice. Okay. Now we're going to add a new radical in here right before kuchi, because that's where tsukamuri comes from. That's where it's inserted. And so we actually want to add one, add a number there, right? So how will we do that? We will, so here, if nr is greater than, now what was that number? It was 30. Okay. If nr is greater than or equal to 30, then nr plus, oh, right. So here we want number equals nr, and if, let's do it this way. If nr is greater than or equal to 30, then n equals nr plus 1. Otherwise, n equals nr. All right. Did that work? No, it did not work. And you go, oh, because I'm printing out nr here. N comma n. And okay, that worked. Great. So let's also format the hexadecimal field so that it's two characters wide, and it's padded with zeros. Okay, that's good. So let's save this into documents, or no, we want to save it into the repository, documentation, and we'll call it radical order. Okay. So we have this much more friendly kind of representation now. Where are we trying to go? What's directory? Radical order. Okay. So now the trick here is that we're going to have to fix the numbers for some of these. So everything that's one stroke is going to be the same radical number. So I will change this to a 1. Right? Okay, so all these lines are 1. And over here, right, all those are 1. Okay. Now what else did we have to fix? Edit, check. All right. So we also consider these 1, 2, 3, 4 characters as having the same radical, as being the same radical rather. So these four are all going to be 9 instead of 9, 10, 11, 12. So let's do that. These 3 are all 9, right? And I will replace this with 9. Okay, and then this 22 and 23 are going to be the same. 22 and 23. 1, 6. Okay, that looks good. And down here we have these 2, right? So 72 and 73 will be the same. 72. But we added 1 here, right? So yes, so we're kind of like using a different numbering system. So this is actually 73. Okay. And then we want to add our new character in here. 30, 1E, and this is tsukamuri, and we can get that character by running this command. You can get an output, right? Here we go. Okay, there it is. So now we have the correct ordering of kanji radicals here, right? So here we actually want to change this. This is going to be 74 becomes 73, right? And well, not exactly. So what we can do here is if radical is greater than or equal to 30, then rad plus equals 1, right? And then we can kind of explain this. Kuchi I ko no bushu. Bushu. I don't know why I messed that up so much. Kushiko no bushu. Bango. Bango. こうすると、no, don't have that. つかむりが口の元の番号を取る。Okay. So we're just saying that radicals with radical numbers from kuchi and beyond get added 1, 2. And that way, tsukamuri gets the radical number of kuchi, what the radical number of kuchi was originally. That's all it's saying. And so let's format this nicely. Right. All right. Okay, and now we want to actually add the tsukamuri characters that we know about from earlier. So let's see here. Now, where are we adding in the supplemental keys? Down here, okay? So these we consider to already have the correct number, the correct kind of radical number here. And this is where we're adding the supplemental characters from up here, right? So I guess what we'll do is let's find that website again, which I was using, which had the list of tsukamuri characters, and we're just going to add them in here. Well, we don't really need to do that. We can go back to the kanji database here and find it. To be right before kuchi right here. Okay, I found it. Okay, here they are. Let's copy these and put them over here. Now, these are all going to have radical number 30, which is, what number is that in hex? That would be 16 plus 14, so 1D, I think. 1D. Well, F is 15, E is 14, so I guess it's 1E. 1E. All right. And let's just go back to where we were here. Okay. 1E. Yeah, 1E. Okay, that's correct math. And here we are going to say the residual stroke count, I believe, is this number here. 87. Trying to prove to myself that I remember this properly. So radical and strokes. Yeah, it's the residual stroke count. So this is going to be 0. And this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, 5. And this one is 1, 2, 3, 4, 5, 6. Okay. And this one is 1, 2, 3, 4, 5, 6, 7, 8. Okay. And this one is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14. So that would be E, because F is 15. All right. Okay, it looks pretty good. I believe that this will now kind of work. I mean, I think that I'm ready to try it. So make new sort, check kanji database order. No. Cannot find the sort key for that. Why not? It's right here. Oh, maybe because it's not in the original listing. Maybe that's why. This is the only character that is like not in the original code point list in the so all these ones, these supplemental keys. Okay, and I was interrupted for a second there, and now we're back. Now, so let's look at this. The problem is that we are trying to add this new character here into the database of radicals and stroke counts, but usually we already have the character in the database and we're just adding a new radical stroke count pair to it. But this one is an entirely new character in the database, and so it's not actually being added to any. It's not actually being added. It's just kind of getting ignored, and that's because here we're looking at the supplemental keys, and if it's not there, then we're looking at the supplemental keys after we read a line and seeing what we should add artificially to that line. And we're seeing that and this extra character just doesn't match any line, and so it's never added. Now, what I think we'll have to do is we'll have to refactor this so that we can kind of add a line artificially. And so we could just call process radso line with a faked line and just give it the actual text that we want in the line. But that just feels a little bit icky because it's kind of a lie, and there's going to be numbers that we ignore, and so then we're going to like add in random numbers that no one cares about, and I don't really like the way that looks. It's going to be kind of confusing to read. So I think I want to like kind of make adding a character and adding a code to it into separate functions, which can be called by arbitrary pieces of code. Now, how are we going to do that? So where are we actually adding the character to the list? Okay, here we are. What is this? Raw character equals that.c. Okay, so this raw ch is what we are. Oops, is what we are writing the character to. So let's see here. Where are we writing it? Writing it down here. And so where are we reading the pairs? We're reading the radso pairs right in this loop here. Right. And here we have the add key function. And so we already do have an add key function. So that's good. So that means that we kind of have to just copy the character in. Adding the character itself is what we have to do manually. We don't have a function for that yet, but adding the radical and stroke to that character is already there. The function is already there. So sort info. We want to add a new sort info element here, and that has a C, a character. And the 5 here is because UTF-8 characters can take up to 4 bytes, and then I added another one for the null terminator. So that's why there's 5 there. And then the sort key. Now, okay, so sort infos has a C. So we can do this. Let's go here. Where are we reading lines? We're reading lines here. So here are, here is this. We're going to add a comment here about this radical. I think I got that. Nope. Let me copy it from over here. All right. I want to say this character is not in the Adobe Japan dictionary. So we'll yank that, and we'll say, okay. Ni haite nai tame shito de te kisuru. So because it's not in this dictionary, we define it manually. Okay. Right. So we're going to say sort infos nr.c. This is going to get the character. So I guess we want to do stir and copy. And how do I use this? Destination, source, and size. Size being the number of characters in destination, or the number of characters that it can consume. So it has to include it has to basically be 5, right? So we're going to do destination, source. Source is this character. Copy this. And it is size of sort infos -c. Okay. And then we want to do add sort infos nr++. Do we want to add to it now? We're using the number of records thing to indicate where we're currently adding into it. And I'm not sure if it's nr-1 or nr exactly, which we're using to index into sort info. Looks like it's just nr exactly. So that means we don't want to add it until we're done adding keys. So add key, and it is supplemental keys down here. So actually we don't really want this. So maybe what we want to do is we want to add we want to do this process rad so line and give it the line, but we only want to give it the character itself and not the rest of it, not the extra fields. And that way we can kind of add in that character for free just using this existing function. Now before I didn't want to do that because I thought I would have to add those fields after it with a bunch of ignored numbers, and I didn't like that. But I think maybe I don't even have to add any fields after that. I can just add the character itself, because right here we're scanning for U plus and that thing. Oh, but I don't want to have to encode the character itself again. So okay. I think I'll just continue with this plan. So I'll delete that. Rad so line, what are the arguments to it? Add key, I mean. What's the arguments to add key? Add key is the radical and then stroke count. So we're going to add it here and then add one to sort infos. Alright, and then we're done. That should basically be all we need to do. Now I'm going to go back here and remove that because we're not using it anymore. And by the way, it's okay that we're adding this character out of order, out of the Unicode sort order, because down here we're sorting it with qsorts anyway. Qsort is a little macro that I have that does it, that lets me qsort and kind of do this a little bit magically, where I just specify the comparator in line here. And I also don't have to do any casting at all, which makes it just a lot nicer. So nice that I decided I would just use a macro for it. Now, I think we may be doing all right here. Let's make, all right, all the tests pass. So now we can do new sort, check kanji db order. Error on this. And what is that error? I don't know. Error. It is smallest matching.radical. So what does that mean? Smallest matching. Check order. What does that mean? So here's the check order function, and we are sorting it according to sorting the kanji database according to radical and stroke count, and then we looping through it, and smallest matching is the so this basically means that something is out of order. So res equals this basically means that smallest matching dot radical is it because we didn't set the cutoff point properly? Radical. When do we change smallest matching dot radical? Smallest matching key equals smallest matching. Sort key compare. Sort key. So this means that we didn't find so we're going to look through all of the keys, all the potential keys that a character has in the sort infos. So we're sorting it according to, we're sorting sort infos for each character, and we're sorting it according to the C, sort info C and character C. So we're sorting it according to the why are we sorting it over and over again? Oh, this is a search, not a sort. We're sorting it, we're searching it, we're looking for the character that matches it in the sort infos thing. And if we don't get any one of them, then we just kind of go down here and then we exit. So down here, we're already getting down to this point in code, and we are setting kanji info to 0. So we're looking through all of the keys, potential keys that that character can use. So there are more than one potential key because different dictionaries might assign different radicals to the kanji. Or they may assign multiple radicals to the kanji for kind of convenience, if like to make it easier to look up. So they will, I remember we had this example here where this character, it has two smaller characters inside of it, and the radical is actually the right-hand side, but it could someone could also assume that it's the left-hand side. And so some dictionaries in this ambiguous case might classify it in a character under multiple radicals, and so that's why there's multiple sort keys. And we're just picking the one that makes we're picking the right sort key that makes our database consistent. So we're kind of picking the most convenient sort key for what we've decided the order is. And later on, we'll probably add a mechanism where the user can look up the kanji using any radical in the dictionary or in the Unicode database. And that way they don't have to know the one that we actually chose, even though we're trying to choose the one that's most canonical and the most correct in each case. So we have smallest matching. So we're looking sort key CMP. So we're looking through. So the purpose of this is we stop when the radical is equal to 0, because that means that we've hit an empty key slot in the sort infos array, because it's just a fixed array, and so we have like 5 or 10 slots or whatever. So we stop at where the radical is 0, but we continue on if it's not, and we compare it to the current key, which is what? What does that mean, key? So key is basically what we chose for the previous character. So we're comparing it, and if it is less than the key, then we don't want to use it. Otherwise, we try to find the smallest matching one. We compare it to whatever was smallest matching, because we choose the smallest matching potential key for each character. That way, we're most forgiving to our database, or we're the most flexible because we're choosing the smallest character that could be as we're looping through the kanji database. And we set smallest matching equal to this smallest matching. We're setting it to the current key, and this means that we didn't actually find anything. We never actually got to this point. The key was always too small. Okay. So how did that happen? So maybe this is wrong. Maybe we need to actually add. Oh yeah, I think we need to use our modified radical numbers here. That's why, isn't it? That's what's wrong. So we're going to go back into doc and radical order, and we want to go to 2C or 9. 2C. 2C in hexadecimal. Okay, so this is now 2D actually. That's why. And 4.3 is going to be probably wrong as well. So the radical is now 44. The radical here is now 57. This is 55.8. Wait, is that right? Yep. No. So this radical is fire, which is 57. All right, and I think that we just want to add 1 to everything, right? Let's go to 73. So just want to make sure. And yeah, that looks like the right one. So that's 73 and A6. All right, that's A6. 87. 87. So this is now 88. And these all should be the same, because this is where we already chose the right number because we just added it a few minutes ago. 1E. Okay, so let's build it again. Check kanji DB order. And that actually passed. That's great. Okay. So what have we what have we done so far? Now, okay, I think that we can commit that. Well, let's double check what tasks we want to do. Vim new sort tasks. So we've done 1, the explanation. We've fixed the failing command, and we want to include it in the repository and run it automatically now. So let's do steps 3, 4, and 5 in the next commit, because 3, 4, and 5 are all about running this check automatically. So I'm going to save this. So what do? We fix fix check kanji DB order command. Also document the radical sort, the radical numbers and sort order that sort uses in its database. I'm going to rewrite these later on we'll translate them. Now we want to do 3, 4, and 5, right? So RadicalStrokeCounts.txt included in the repository. So this is pretty easy. So I'm going to go move my copy desktop/unihan/unihan RadicalStrokeCounts and move that to let's move the entire directory. Not the entire directory, but move the directory kind of structure. So I'm going to I don't want to do that because I don't know. I'm probably not going to store any more of this data in the repository anyway. So I'll put it in third party. Right. Okay, and now it's not going to work because I actually have the search path for that file in hard coded in the code, right? Okay. Now, so we want to fix that. Let's open it. Let's open check kanji DB order and go down to Unahan radical stroke counts. So look in home. Well, I don't want to look in home. I think I just want to use relative directories, or yeah, relative directories. So I suppose what we'll do now, probably the right thing to do is to figure out what the binary path, what the path of the binary being run is, and then choose it relative to that binary path. But I don't really feel like getting that involved at the moment. And so what I will do instead is just do a relative path, assume that it's being run from new sort/source as the working directory. So we'll do go back up and then go into third party and run it from there. And we don't need this thing anymore. Delete to. Okay. All right. We no longer need to kind of calculate the database path free. Yeah, that's nice. And I might be able to delete that xasprintf utility function now. I have a feeling I'm not using it anymore. Git grep xasprintf. Nope, I'm still using it once. But I'm probably going to use it again, so I'll just keep it. Once is enough to justify keeping it in this case, I suppose. Okay. Now we can make. Okay, that worked. Good. Now we are going to go ahead and let's go back to the task list. Now we're adding a Q argument to make it not print out anything. So I think that the usage is showed here. Yeah. /Q. There's a documentation for it. Check kanji DB order. Now, so DB out. Where are we actually parsing it? DB out. Oh, it's a dash, not an underscore. Did I do that right? Did I document as a? Yeah, it's a dash. Okay. Sometimes it's a dash, sometimes it's an underscore. At least in my experience, I wish it would just always be dashes. It's a little more consistent. It's more consistent with the two dashes in the front. Anyway, we are now going to add a -q argument to check kanji database order. And we are, let's see, we're here. We are checking for a --, which separates this with a list of explicit radical cutoff characters or cutoff character list. And so let's just put it right here. It's Q. If it's Q, quiet equals 1. All right. And so we need an variable to hold that. Static int quiet. Okay. Then let's see here. Where are we actually printing stuff out? Like the standard out. Where is standard out print? Maybe I did a printf and that's why I'm not finding it. Okay. Printf. Here we go. So So output character line. All right, and it distinguishes between database out and output database. It distinguishes between two formats here. So here we're going to say if it is else if not quiet. Well, that's not going to work. If quiet, let's see, if not quiet. Okay. Now I'm annoyed by the fact that it is the negative is first, the negative branch is first for no real good reason. I'll just let it go, I guess. Just let it be. If not quiet. Okay. Okay. So now I guess we want to add, maybe we can just add a normal test. Add a normal test rather than add this to the make file. Add this to the make file is like invoking the command directly. I don't see why we really want to, because adding this to the make file as like just invoking a new sort as if you were a user is a little awkward. So maybe I will add this as a real test. So yeah, let's change this so that it uses the mockable file output stream for standard out. All right. That way we can test it. And so let's try running it manually. No. What was it in? What was out declared in? I think it was in commands.h. Yes. Okay. So what are the tests we already have? Can we add it into an existing test? Last rank contain test, make map test, rank coverage test, Romaji test, and test util. None of these really match. None of these really fit in with check kanji database order. So I guess what we'll do is make a new test case. So let's open the make file and test sources. So last rank contain test. That was the last test we added, I believe. So we'll just copy it, and it's going to, if we do it alphabetical order, this will come first. Check kanji db order test. Check kanji db order test. All right. Check kanji. All right. So that's the boilerplate in the make file that we need. Oh, we need to add it down here. Check kanji database order test. Okay. So edit, check kanji database order test. And we'll read it in the last rank contain test as a guide. And you need commands, we need test util. I don't think we need util. Let's just get rid of that. And end test, start test. Okay. Let's just get rid of this. We don't need this. And we're going to go ahead and start test. and we call it check kanji database order test quiet, right? And then we say check kanji database order, and let's see. So we pass the argv and then the argc. So I guess we just want to do this. Argc is 1. I don't know if that's actually going to work. Just for consistency with the other tests, we'll indent it in its own block. End test. Okay. Out. And exit. Right. Okay, that should be a valid test. Do we need any other stuff? We already have test util. Let's make... we do need util, huh? All right. We need util.h. Q. Okay, it doesn't like my little inline constant here for the argument argv array. It seems. So expression. Okay. I think we want another constant here somewhere. So we don't need const here itself, right? We don't need const there. That's just the pointer itself. But when we dereference it, we should get a const here. I think we want two consts like that. Types const car const. Types. Okay. Let's look at some other test case and how it declares these arguments. Const car args. Maybe it's because we need to give it a a subscript there. Okay, that worked. Okay. All right, so it has this extra line where it's saying the number of characters it actually read in, which I don't like that much. I don't really like having to say that. So we'll just have to also use xfprintf to the mockable stream in that line as well. So we got to go to check kanji database order, and let's see, we're looking for yomi komi, which means load. All right, here. xfprintf error. Now maybe we should just go through this file and change all of the standard error and standard outlines. Like, so we want to do standard error 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Was that 11? Well, it's quite a lot. So let's just use a find and replace. So we'll do fprintf standard error, replace that with, I messed up this line. Oops. So F to go into edit, this kind of mode, So we want to say %s slash xfprintf error. No, that didn't work. I need to start over. Fprintf standard error, replace with xfprintf error 9. Okay. Now we have to reindent, unfortunately. xfprintf error. Maybe we don't have to indent every instance. All right. All right. I think that's everything. All right. There, it hit the bottom. All right, I think it's ready. So now if we try and run it, it's going to not get the output expected because it's going to have this extra line, right? This extra line about the number of characters read in. So let's copy this, and we're going to put it in the expected output here. Right? Let's try it again. Okay, good. So now all the tests pass, and so we're done with this exact task here. So let me look at the new sort tasks. So we automatically run kanji DB order as a test when running make and add a -q argument, include the RadicalStrokeCounts.txt file in the repository. We did all of that. And I don't need this script anymore. And yeah, so I think that I saw something else I wanted to fix. So we'll say, let me just say what it is here. It is to use grow array by in check kanji DB order here. Oopsie. Did not mean to do that. Okay. Save it. All right, so check kanji DB order.c. So I noticed here that I've hard-coded the number of items in this stupid sort info list, which feels silly, and this number looks random. It's supposed to be 13,450 or whatever that number was before to accommodate all the characters, but I don't really like the idea of hard-coding this value here. It doesn't really look all that right. So I'm going to use that array, this dynamically allocated array utility function, and we will say that we have a static struct with sort infos. Oh no, we have to call it L, right? Struct sort info L and size t count and size t alloc. And this is going to be in the sort infos thing, right? So that should be valid. And this is static, so it's going to be initialized to 0 automatically, as far as I'm aware. So sortinfos.nr is now going to be sortinfos.count. So 1, 2, 3, 1, 4. Okay, I thought I saw like 7 or so in there. So yeah, wonder if we should just go one by one and fix all of them, because this one is kind of different. It's going to have it's going to require incrementing the count value, which used to be called NR. It has to increment the count value like as it's adding the item to the array and as it's growing it. And so this pattern here we had of NR not growing until like we're done setting up the value is not going to work anymore. And so let's say, yeah, what's the best way to fix this? Because I don't really want to have to I mean, what we could do is do sort infos dot element sort infos dot count -1. And that's a bit cumbersome. So maybe we'll just say static sort static. We'll make a function to do that. Sort info last si and return address of sort infos.l sort infos.count -1. All right, there. That should make things a little bit easier. And now we don't really need this si anymore, as far as I'm aware. Last si. Last si. Last si. Si. Okay. So let's look for the next use of sort infos and make sure that it's all right. Raw ch. Raw ch. Okay. Now I'm wondering how this is used. Is it safe to just change this to a lazy call? Let's do this. Let's change this to last si dash c. And that's more straightforward. Sort infos. Two keys. Okay, and this is going to change. Sort. Let's just go last si. Right. Okay, now we have to make sure we grow it before we start adding to it. Although let's check the other usages and make sure that we're okay. Sort infos dot l and sort infos dot count. All right, and down here we're going to say grow array by, and it will be sort infos grow by 1. And down here we do last si dash c. This is last dash si. I wonder if I can put a function call inside of size of. Is that okay? It sounds kind of wrong. Anyway. Oh, I never actually committed the last thing I was doing, did I? Well, that's embarrassing. I guess I'll just deal with it. Have a commit that has a lot of junk in it. And sort infos. So sort infos. Oops. Insert dot l and dot count. Sort infos dot l p. Count. Okay, now where do we have to grow it? We have to grow it, I think, when we are reading a line. We've got to grow it here. Process rad so line. So grow array by, and we call it sort infos 1. Okay. Now this should all work as long as I don't have any compiler errors. Function declaration isn't a prototype. Last assign sort info. Sort info. 56. Old style function definition. Function declaration isn't a prototype. Oh, I think I need to add the void here. Maybe. Yeah. Ooh, it's freezing. That's interesting. Oh, what happened? Last SI. SIC. SI. Jeez. I wonder what it's freezing on. Typical cookie kanji with showing, count, and hide kanji test. So is it actually running? Yeah, it's running the check kanji database order test, and it's freezing. I wonder what it's actually freezing at. Go away by sort infos by 1. Process threads line. Okay, how are we going to figure this out? I might have to do some like printing. So maybe I'll print a little message here, and I'll print it directly to standard error, and it'll be like, you know, processing line. Okay, so maybe we'll get an idea about when it's freezing. Processing line, end of file. Huh. It freezes at end of file. Yeah, okay. So maybe it's already finishing all these function calls. And down here, printf after loop. Let's see if it reaches that point. No, it does not, but it does read end of file. So oh, looks like it actually okay. It wasn't frozen, it was just taking a long time. Number of keys is wrong. Okay, what is the difference here? What is 77? I wonder what's the factor of incorrectness here. 77550 divided by 13454 is 5.7. That doesn't seem particularly telling. I would expect it to be a more rounder number, like 2 or 3, like an integer, closer to an integer, but it's not. So is it not starting out? Let's make sure it's starting out at size 0. Initial size is sort infos.count. Let's try again. It didn't print the message. Do I have to wait till it's done? I wonder why. Shouldn't standard error get flushed immediately? Initial size. Why am I not seeing the initial size line? Oh, it's over here. Initial size is 0. Okay. Oh, so I'm growing it. So not all the lines are actually valid. That's why some of the lines don't have any like input on them, and so it's wasting time here. It's wasting time growing the array each and every iteration. We don't want to do that. So line. So where does it return here? We want to grow it after it's finished all of the potential early returns. Return. Okay, this is the only non-error. This is the latest non-error early return right here. This is when it's checking if something is from the Adobe Japan dictionary. So let's grow the array here. That should work. Should be better. Segmentation fault. Because we're calling last SI here, I guess. It's probably not good. So let's initialize it. So where's raw ch? Where is it used? Here, okay. Last si dash c. Last si dash c. Okay. Now let's see. Raw ch is not used. Okay. Great. Now that's very good. So we've basically succeeded in using this cleaner method of growing the array. And this is not so great. This is also like a hard-coded limit, but it's kind of a smaller thing. I think I'm okay with this one. I mean, I don't want to just I don't know if I need to fix that. I mean, to be consistent, I should fix it, but this is not really as kind of jarring as the other problem. So, yeah, okay. Now, I think what I'll do is I will commit this, but maybe I wonder if I can actually try and save the work separately, where I was refactoring to use the grow array by thing. Maybe I don't have to. Let's see how check kanji database order, because I think that's the only file that I screwed up on. I shouldn't have been changing it. The other files can be committed soon. So quiet, there's commands. I do want that. And I'm just wondering if everything is really completely like if the two changes are well separated. Maybe it's not worth it. I think I'll just keep it as it is. I'll keep all the work in a single commit. That's fine with me. So, okay, let's add this and let's review what we've accomplished. So we've added the check kanji database order test, which is essentially just calling the command like directly, calling it as a test, which doesn't output all of its analysis. And we changed the check kanji database module to use this cleaner like array resizing mechanism. We did other refactorings like to make it more testable. In order to make it more testable, and the way we did that was use the testable mocking functions, and then this is more the array refactoring here, and this is more testability refactoring and array refactoring and decode code point. So actually it seems as if really a lot of this is just the refactoring to use the array. So okay. Okay. Yeah, there's nothing here that I haven't mentioned already. And here's what we really wanted to do that was most important: add the Tsukamuri character radical and stroke count information. Then this is our tests like boilerplate, and here is the updated help, and here is the added stroke counts data, radicals and stroke counts data. That's going to be very big. But it's like, how big is it? Not that big. It is about 2 megabytes. That's not that bad. Okay, I am going to commit this, I suppose. What else did we do today? Last string contained fix check kanji database order command. And then we are going to, so you know what, I think I will actually extricate the two different kinds of changes that we made in check kanji database order. So I'll get rid of the refactoring stuff. So I think I'm going to copy this file because I'm kind of afraid that I'll do something I didn't want to. Check kanji database order.c. So I saved it. I think I want git reset, if I'm not mistaken. That will unstage the changes here. Yes. Okay. So now we're going to do an interactive add of this file, check kanji. And the point of this is to include everything except for the array refactoring thing. So here we do want to stage this. This is not related to array refactoring. Here we don't want to stage this. Nope. And here is a testability refactoring. So yeah, we'll keep that. And here it has two kinds of changes, it appears. So it has it's the array refactoring here and then the testability refactoring here. So I think we want S to split it up. And so here we don't want it do that one. That's the array thingy. Here's array stuff. This is testability. And split this up. We do not want this. This is the array, and this is testability. Stage this, not this, and stage this stuff. Oh, did this line get too long? No, it should have gotten less long, right? Yeah, this line is less long. Okay, I was hoping I didn't have to rewrap anything. So this and decode code point and comp last SI. Okay, so this is array stuff, right? This is like the last SI thingy, so we don't want to stage that. And here this is testability, so yes. And this has to be split up. So split, do not stage this, and do stage this, please. And SI, SI. Yeah, this is all non-array refactoring. So DB path. Yep, that's moving stuff into the repo. That was not in it before. And here is the more of the not storing this file in the repo itself. So this is wanted and sort infos. Okay, it looks like this has some stuff mixed up in it. So I'm gonna have to change this. Edit it manually. And okay, so this we do want. It's removing that. No, do we? String copy last SI. Okay, we're removing that. We don't want this yet. We don't want grow array by. Now we do want string copy. Delete 2. Last SI. So what did this look like before? It looked like sort infos. I'm gonna copy this. So basically we don't want to change that line, right? So we don't have to actually go through this. Right. Yeah, that's simple enough. Okay. Sort infos. Okay, so this we do want. no. This we don't want to delete. Well, we want it, but we don't want it. So we want except printf sort infos, but we want this to be actually underscore nr still. And then this is this I think stays the same. We don't want to change it. So I'll just do replace this, replace that. Okay, I hope that works. This is kind of like getting involved, more involved than I was expecting. But it looks like everything's used correctly. All right, so I'm going to say what we did here. Let's look at the task list. Not vim/sort. Right. And I'm going to, oh, I don't have the clipboard. There we go. I'm fine actually. I was going to say I don't have clipboard integration working yet, but actually it's working good enough that I can copy it like that. Okay, git log. All right. So I'm obviously going to rewrite that later. And then gd. All right. And let's commit this as array refactor. All right. Now let's make sure this builds in the partially committed state. Let's make sure it still works. It does. Very good. Git. So let's do C1. So this is the array refactoring only. And C2, commit 2, is everything else we did today, the stuff that was actually planned. Now, I think that we'll just call that finished for now. I don't really have anything else planned at the moment. So rather than, I do have some notes here. Allocate with macro and size. Yeah, well, I already did that. I just wrote down that I want to do the macro refactoring here, and then generate line stats and make map. Oh yeah, so what we'll probably do next time is in make map we generate line stats. So we kind of want to yeah, we want to, the next is to actually make map generate the kanji codes. And in order to do that, we will have to go to last line contained, and we're going to have to refactor out the logic that generates line stats here. So the line stats is just each line in the last line contained command, right? So each line here is going to correspond to a certain set of codes which all contain the same first character in the codes, the same first key. And what we need to do is we need to allow MakeMap to have access to this data programmatically. And so I'm probably going to refactor out line stats, this like line stats generation logic, to be a separate module. But for now, let's just end the video here. It's a good time to end it, I believe. And thank you for watching.